Hello everyone, today we're going to do a teardown of the Multifire Endo GIA straight stapler medical device. This is not a video that's going to show you how the device works. For that, there's tons of videos on YouTube that show you how the device is supposed to be used and how it is used during surgery. The purpose of this video is to tear down, meaning disassemble the entire device, look at the individual components, and try to figure out what mechanisms this medical device utilizes to work properly. We may not figure out all the different mechanisms, seems like there's quite a bit of them going on, but at least you have an understanding of the parts that make up this device. And this video is sponsored by Pipeline Design and Engineering. You can find us at designtheproduct.com, and we specialize in making medical device test fixtures for medical devices, very much like this one. So let's get to it.
Oh, I think it's like, you're right, it does like split right here. You can tell by the parting line. So these two halves somehow come apart. I would maybe see try taking this part off right here first, and maybe that's keeping those halves together.
It looks like it's internal grip pins that are holding this together, so we may have to pry this open. Otherwise, we don't see any screws that we can unscrew. So I just whacked it with a hammer and it helped it open. And now I'm trying to pry it open with a screwdriver. Appears to be a dowel pin. Just gonna have to break it. Okay. At least we know how it works internally now. Had to break it, as you can see. So the way this works is when one actuates the handle, the pinion inside is gonna actuate the gear, and it's gonna move this gear in a linear fashion that way, which is gonna activate the staples on this end. Now, right now, I broke it to have access, but if you could imagine, you pull the handle, it rolls, and those teeth engage with this one up top, and that causes the linear motion. This liquid that we see here, that's why I put on my gloves, is lubrication.
You know, I might need a... Can you hand me some needle nose pliers?
Hold on, let me give it a shot. There. And this was... Well, we use dowel pins here. Dowel pin up there, dowel pin down here. And this linkage, what do you think is the purpose of this linkage right here in yellow?
That looks like the return linkage for the lever. So when you actuate the lever, the job of that is to return it to its nominal position.
What would be a nominal position?
Probably the closed position of the jaw.
So this is closed, open. Yeah.
That's probably...
There's a channel for this to slide. It slides right there. You're gonna think that we're savages, but it is very difficult to find a way to open this shaft, so I may have to use the hammer, which is kind of fun, but if there's a way to not break it, that would be ideal. So move this forward and backwards makes the jaws close. All right, so there we go. Success. A lot of lubricant. We have an O-ring. what's holding it in place and preventing from it opening is this, I suppose it's like a metal O-ring. So I need to get that out. Easier said than done. This was definitely made so that you don't take it apart. But I wonder how they got this in here. Maybe they changed the temperature of the metal and they made it shrink. They had to tighten this metal to get it all the way down this shaft. I'm trying to get this ring out.
Probably a press fit.
How would they slide it down this shaft though? It's so hard.
They probably have like a machine that presses it down, like specifically like, and has an opening just wide enough to fit over this, and it like slams the ring down.
So I guess I learned something new today. Did you know that they can use that to prevent it from opening, just to secure?
I never seen it before, but yeah, it totally makes sense. Looks like it's about to come off.
You want to do it on the camera? This is the frame. Yeah. Maybe that lubricant's coming in handy.
It's either that or it could be they put the pieces together and they heat this up.
That's what I thought. There we go. Woohoo!
Yeah. Compression ring.
I see a lot of channels that will facilitate the translational motion. So that's an often mechanism used to facilitate that motion. There he goes. All right, so I used the hammer to break the outside shaft made of this material. And now we have the metal shaft, and this goes through inside the metal shaft, and I want to get to the inside, see if I can extract whatever's inside so we can understand how this is happening. All right, so I used the hammer and a screwdriver, and I put the screwdriver at an angle. I hit it with the hammer, and I was able to take the inside out. So this is what was inside. So let's take a closer look. I'm gonna grab the one on top and I'm gonna slide it out. Back and forth, okay? All right, so that was the full disassembly. Requires some brute force. As you can see, some of these medical devices are made in such way so that the user cannot disassemble them themselves for safety reasons. So that they make it so that if you want to disassemble it, you're gonna have to break the device. I look forward to some of the comments. If you guys could let me know how maybe I could have done this disassembly better, or what you learned from this disassembly. I'd be very interested in hearing your feedback. We read all the comments, and we look forward to that. Like, comment, subscribe.